as we are establishing the basis for these cells to find the tumor and act on the tumor or on COVID on their own behalf, we also realize that in specifically certain solid tumor settings, that may not be enough. They will have a very suppressive tumor microenvironment. They will be cold. What should you then do to actually enable these cells to really have an impact on the tumor? And that gets us to modifying these iNKT cells to become even more effective than they would naturally already be in tumors. And that brings us to bringing CARs into these cells. So we have a number of programs going on that would bring CARs into iNKT cells that are specifically tuned to work with the endogenous receptor array that and signaling capabilities that invariant NKT cells already have, and work with the NK receptors, with the TCR that recognizes CD1D, and enhance those properties with adding an additional targeting and also additional signaling capabilities to these invariant NKT cells that boost them beyond what they can naturally already do. So we have several programs. We also have a technology that allows us to develop these CARs in a way that very early on already gives us a library of cells with different CARs, and then through exposure of these cells to a variety of tumor cells in Coculture assays allows us to fine-tune exactly which CAR, the affinity with which it recognizes its target, but also the type of signaling domains that we endow this CAR with, what combination actually would work best for a specific target and a specific tumor type that we are interrogating. And that's quite a task, because for every surface expressed cancer target, there's not one that is truly 100% specifically only expressed in cancers. There's usually a very high upregulation in cancers, but there's also a certain amount of expression outside the tumor. And you really want to use that therapeutic window and not cause any off-tumor on-target toxicity outside. So really being able to tune the activity and the response of your cell therapy with the CAR to only really work in the environmental context of a tumor bed is going to be very important. And that is where our sort of vision platform comes in. And we are developing that together with Agenus. And the basis of it is a number of different Coculture assays that recapitulate elements of the tumor microenvironment. For instance, the one that we have already demonstrated to work and which many people are now using is this progressive exhaustion of T cells. You can expose T cells to tumor cells, and then by refreshing the tumor cells every 2 or 3 days, you can progressively push T cells into exhaustion and study that process. We've used it as a basis to investigate when, for instance, a molecule like PD-1 would have an impact on preventing or delaying exhaustions in T cells. And we've seen some very good windows. So the terminally exhausted ones you cannot rescue, but also the very fresh ones don't really benefit from PD-1, but somewhere in the middle on the process towards exhaustion is where you see the impact. And we're doing this with a number of other molecules in the Agenus pipeline. Translating this to Agenus, if you do this with a library of CAR-expressing cells and you push them to see how long can you actually keep them actively killing tumor cells, will already allow you to define a window of activity that gives you enough tumor kill but doesn't drive you to exhaustions too fast. So that's the first parameter. The second one is bringing in, for instance, a myeloid suppressive component. That's currently hard studied. There's a whole wave of new targets that are getting looked at in the myeloid subcompartments in the tumor microenvironment. We recapitulate this in a number of Coculture assays where we bring in a myeloid compartment, myeloid-derived suppressor cells or tumor-associated macrophages, together with invariant NKT cells and tumor cells, and then see how the dynamics of that process change, how the suppression of an immune response by myeloid cells actually changes when iNKT cells are there and are actually getting activated by the tumor. That really also allows us to study the right combination of the CAR and the iNKT cells to really work in the context of this myeloid suppression, for instance. And there are other type of Coculture assays. One other particularly interesting one that we are currently trying to set up is, aiming to set up, is where we also bring in NK cells. NK cells are really the soldiers, the killers of the immune system. They're rapidly attacking anything that is foreign. And if you can rally them behind the general attack on a cancer, that will be fantastic. And it's known and well studied that invariant NKT cells actually orchestrate a response through, for instance, secretion of high amounts of interferon gamma, higher than normal T cells, that bring in T cells and NK cells in the site where they become activated. you would like to study how this works best and how you can enhance the attraction of NK cells and the activity of iNKT cells together with a CAR to really make a decisive impact on a particular tumor environment. And that's where, you ideally want to do this in an in vivo setting. Mouse models are one way to do this. The step before that is to try and build a number of more complex Coculture assays that recapitulate a number of the properties of the tumor microenvironment in a way that you can study it. And what is helping us enormously is the ability to single cell interrogate these cells. It's not just single cell sequencing, it is also technologies like CITE-seq that allow you to look at a digital fax expression of antibodies on the cell surface. And together, those will actually allow us to really study in depth how the exhaustion process goes, how the myeloid component drives or doesn't drive the suppression, and what iNKT cells do in response to certain culture conditions or tumor target expression levels, for instance. It's quite an integrated system, but it's, in our mind, the only way to, with high fidelity, develop a cell therapy that has the right level of activity in the right context, which is key for having them work effectively and not cause toxicity.